In this video, I'd like to talk about a few things. The first one is what is a line segment, so I'm going to define that and how that's different from the distance between 2 points. Then I'm going to talk about the length of a vertical line and the length of horizontal lines, which is essentially the same type of thing. And then we're going to talk about finding the length of any line segment. So let's get started. The first thing is to talk about points, really. So we're talking about ordered pairs on the graph. And let's just say I have 2 points, like one right here, and we'll say another one right here. Well, I'll make it a little bit higher. Let's go right there. Okay, now these are 2 ordered pairs, and this one is -4 and 1, 2, 3, 3. Okay, so it might not be exact, but we'll say that's what it is. Okay, and this is 1, 2, 3, 4, so this is 4, and 1, 2, 3, 4, 5, 4, 5. Okay, now these are just 2 points. Now, if I wanted, what I would do is I could draw a line. Well, not if I wanted, but in a specific situation, I might draw a line between these 2 points. And this is referred to as a line segment. Alright, now, the reason why is because a segment means part of, right? And so, when you're talking about a line segment, you're talking about part of a line. Okay, now, in mathematics, typically what we do is we talk about a line, so we might have something like, I'll just use a linear one. Okay, so we might have just something like this. And then what I would do is I'd be looking at a line segment, so a portion of this. Now normally this goes on forever in both directions. Okay, but what I would be doing then is talking about a portion of it, so I might talk about like from here to say here. Alright, so that's a segment of a line, and hence it's referred to as a line segment. Okay, so that's what that is. Now, when we're talking about the distance between 2 points, what we're doing is we're talking about the distance, say, from here to here, but not necessarily the line in between. And the reason why is because the line in between might not be a straight line. For instance, it could look like that, right? In which case, it wouldn't be the straight line distance between them wouldn't be the same as the actual line segment. Alright, now, in every example I'm going to do in this video, all the line segments are going to be straight lines, so the distance between the 2 points and the line segment would be the same. However, they're not necessarily the same in all lines. Okay, now, when I'm finding the length of a vertical line, what I'm going to do is I'm just going to draw a vertical line here. Okay, so I have a vertical line segment. I'll take 1 point there and another point, say, right here. Alright, and what I'm going to do is just draw a line in between them. Okay, those lines are unusually thick. Okay, and so I got something like this. Okay, and this point here would be 3, 1, 2, 3, 4, 5, 6, 7, 8. So 3, 8. And this would be 3, -2. Okay, now when I'm finding the length of this, I don't really care about the x-coordinate. And the reason why is because the x-coordinate is the same. It's 3 here and it's 3 here. Okay, so it doesn't really matter because the line hasn't moved anywhere in the horizontal direction, so the x-coordinate is really irrelevant to the question. Okay, now what we do then is, let's call this point A, and we'll call this point B. Okay, and so what I can do is I can say the length from A to B, and I'll just put a line above it to say that's what it is, okay, is equal to the AY minus BY. Okay, and what I mean by AY is the Y component of A. Okay, and BY is the Y component of B. Okay, so I got the length from A to B is equal to 8 minus -2. Okay, and then the length from A to B is equal to 10. Okay, and it makes sense because it goes from 8 to 0 here, which is 8, and 0 to -2, which is a length of 2, so that's a total of 10. Now, a lot of times people will ask, well, what if we reverse this equation? Then we're going to get the wrong answer. Now, one of the things is it doesn't really matter, okay, because if you measure A to B, it should be the same as B to A, and we'll see what happens here. Okay, BY. We're going to see what happens, and we're going to modify our equation. Okay, so we've got B to A is equal to negative 2 minus 8. Okay, and from b to a then, okay, what we get is negative 10. Okay, so however, a length of negative 10 doesn't seem to make any sense in a length situation. Now the reason why this happens is because we are dealing with what's called a vector quantity, because with a scalar quantity, okay, it's the opposite of a vector. Okay, a scalar quantity is a quantity where the direction doesn't matter. Alright, so when we're talking about a vector quantity, we're talking about a quantity where the direction matters, and the negative sign here is just indicating the direction that we're measuring in. So it's not really that big of a deal, right? So what we're going to do is just modify the equation that we have here, okay, to make it work, okay, to make it fit what we're trying to do. Okay, and so what I'm going to do is I'm going to say that this is actually just the absolute value of ay minus by, and then it won't matter if I put where I put a or where I put b. Okay, yeah, it doesn't really matter, because if it became negative 10, then the absolute value sign would mean that it become positive 10, and so we're really just looking at the positive value all the time, right? And so this is how you find the length of a vertical line segment. Now, if this were horizontal, it would be exactly the same thing. Okay, so let's take a look at that. I'm not going to be able to erase everything here, but that's okay. Okay, and what we're going to find is we're going to get pretty much the same thing here. So I'll take a line segment like this, a little bit lower, okay, something like that. Okay. And let's say, for instance, it's negative 1, 2, 3, 4, 5, 6. So this is negative 6, 1, 2, 3, 4, negative 6, 4. Okay, we'll call this point A. And 1, 2, 3, 4, 5. Okay, so this is 5 and 4. And we'll call this point B. And if I wanted to try to find the length of AB, okay, it would be the exact same thing as finding the vertical one, pretty much. Okay, now, in this case, the y component doesn't matter because the line doesn't move up or down in any direction, so it doesn't make any difference and we can just ignore it. Okay, so what we get then is that we're going to just look at is equal to ax minus bx. Okay, and once again we're going to be looking at the absolute value of this, and the reason why again is because this is a vector quantity. It matters about the direction, like where we're starting measuring and where we're ending measuring, and that's going to give us a different number. However, in these sorts of questions we really just care about the overall length of the line, and so it doesn't really matter to us if it's going to be positive 10 or negative 10 or whatever it is. Alright, so let's take a look and see what happens here. So we got the length from A to B, okay, is ax, so that's negative 6, okay, minus bx, which is 5. Okay, and we're going to take the absolute value of those. Okay, so this is going to be the absolute value of negative 6 minus 5, which is negative 11. Okay, and then AB is equal to positive 11. Okay, and that's really it. Okay, now when we get through this, we can get to the third part here, or part 4, I guess, and part 4 is a little bit tougher. Okay, now what happens if the line is not a horizontal or a vertical line? Okay, if that's the case, then what we're going to do is we're going to use what we learned from 2 and 3, and we're also going to use the Pythagorean Theorem to help us out. Okay, let's take a look. Let's say I give you a line like this. Okay, so starting here, and we'll go down to here. Okay, we'll say that this is point A. Okay, and A is 1, 2, 3, 4, 5, 6. Okay, so 6, 1, 2, 3, 4. Okay, so 6, 4. Okay, and B is 1, 2, 3, 4. So negative 4, and 1, 2, 3, 4, 5, 6, 7. Negative 7. Okay, and we'll call this B. Alright, so what we're going to do here is we are going to use the Pythagorean Theorem, and we're going to draw a right angle triangle with this. Okay, so let's take a look. We take the green line, and we'll draw a line like so. Okay, and then I'll use that purple line, and I guess I'll make that one purple. Okay, and I'll draw another line here. I'll make this one green. Okay, and if these are true straight lines, okay, what I should notice is that this would make a 90-degree angle, which would make this a right triangle. Okay, now if that's the case, then we can apply the Pythagorean Theorem to this triangle and find out what the length of this line is. Now this would be great if we knew what the length of this is and what the length of this is. But we do from what we just learned about the vertical and the horizontal line segments. And what we can do is we can find out what this is by looking at just the y values, and what this is just by looking at the x values. Okay, so let's just call this the x. Well, we'll call this the x, and we'll call this the y. Alright, the x is the horizontal, the y is the vertical. In fact, I will call it delta x and delta y. Okay, so this delta is a math term meaning change in. Okay, and so this is the change in x, and this is the change in y. Okay, and so if I was going to use the Pythagorean Theorem, okay, I'll call this length. Okay, then the length would be equal to the square root of the change in x squared plus the change in y squared. Okay, so something like that. Alright, this is just the Pythagorean Theorem, where the Pythagorean Theorem says c squared is equal to a squared plus b squared. Okay, so where c is the hypotenuse of the triangle, so c is equal to the root of a squared plus b squared. Okay, in this case a is this, one side, and b is this, the other side. Okay, and I'm finding the square root of it. So it's exactly the same as the Pythagorean Theorem that you probably know from before. Okay, so I have the length here is equal to the square root of the difference of x. Okay, so x goes from 6 to negative 4, so that's a value of 10. Okay, so 10 squared plus, now the change in y goes from 4 to negative 7, so that's 11 squared. Okay, so the length here is equal to the square root of 100 plus 121. Okay, so the length is equal to the square root of 221. Okay, and let's pull up the calculator and see what that is. So 221, enter, where's the square root? There it is. So 14.9. Okay, so length is equal to 14.9. Okay, and that's really it. Okay, so what we do is we just draw a triangle and we measure the difference of these, which is finding the vertical line segment and the horizontal line segment, and then that's it. We just use the Pythagorean Theorem to find the length of the line. Alright, so if you have any questions, please feel free to drop me a question in the question box or send me an email and I'll try and help you out. If you do like the video, then please give me a thumbs up, and if you do like my channel, then please consider subscribing.